Good morning, namaste and warm welcome. My dear students, guardians and all the viewers who have been watching us in Kaliga SDTV, its Facebook Live and from YouTube too. I am Prakash Subedi, a mathematics teacher, and I have been teaching for standard 9. So, dear student, we have learnt about geometry theorem first and second till last episode. So, today I am going to introduce a completely new lesson for standard 9. What is that? Before starting, let me see. So, what is this, dear student? Have you seen? This is a coin and this is head and this is tail. Now, if I toss this coin and on the plane surface, if we toss a coin, then either head comes or tail comes. Okay, let us play a game just for once. Okay. So, I am going to toss, you guess yourself whether it will be a tail or it will be a head. I am going to toss. You remember in your mind, you choose either head or tail. I will tell the answer. Let us see whether you win or not. Look, I am tossing the coin. So, did you choose either tail or head? I have also not seen yet. Okay, let me see what came. It's a head. I got head. Okay, congratulations to those students who were choosing head, and then for those who chose tail, better luck next time. So, regarding this sort of activity, so one thing you should be clear that when we toss a coin, there will be two options, either tail or head. Similarly, have you played Ludo? There a dice, we roll a dice, and when we roll a dice, then some numbers appear at the top surface of the dice. People playing cards, 52 cards are there, and then they play it, yes, and they get a card, what it may be, any one out of those 52 cards. So, today we are going to discuss about all these matters, dear student. This is very much interesting chapter. So, this is probability. So, let me show you a slide please. You can see there about the probability. So, dear student, you can see in the screen there three face cards are there at the top left side of your screen, TV screen. You can see J, Q, K. These three cards, they are known as Jack, Queen and King. Similarly, you have seen coin, and a coin has tail and head. You can see both parts. You can observe there of the coin. It is a 2 rupee coin of Nepal. You can see one side that Mount Everest, that is tail, and next one a farmer plugging field, that is the head of the coin. Similarly, you can see two dices are there. You can see 6, 5, 3, 1, 4, 2, all the numbers are seen. And then you observed there are some playing cards. So, in one side I have listed out all 4 kings, and at the right you can see 13 cards are there. First one is A, it is ace, then K, it is king, Q, it is queen, J, it is jack, and then 10, it is obviously 10, 9, 8, 7, 6, 5, 4, 3 and 2. Including this, the 13 cards are there. You can see all of these are black in color, and then they are spade cards. Okay. So, this is what we learn about in probability. Let us see how much we can do today. Today, I am going to focus in general terms, some definition, some knowledge about the probability. So, let me show you the second slide. So, you can see the student, we mainly discuss about tossing a coin, rolling dice, and about playing cards. Here you can see 4 cards I have shown of ace. There are 5 cards are there. The down one is heart of ace. You can see 4 cards, they all are A, and they are regularly ace of spade, heart of spade, ace of spade, ace of heart, ace of spade, and ace of diamond. The 4 cards are shown there to identify about the color, the student. That first one is spade one, second one is heart, third one is club, and the last 4th one is known as the diamond. You can see among them spade and club are black in color, and heart and diamond are red in color. So, if possible, please let me see this the slide in PIP, please. I hope it is we can see in the PIP. Okay, I hope you can read this, the student. So, how many surfaces are there in a coin? First question, very easy question. Look, this is a coin. This surface number 1, this surface number 2. It has got 2 surfaces that we discuss. Okay, look, if I toss the coin, either either head surface or tail surface occurred. So, a coin has got exactly 2 surfaces. Now, let me see the second question in the PIP, please. So, as you saw, what surfaces can be observed when we throw a dice? So, dear student, when we throw a dice, you can see dice in PIP. After coin, you can see 2 dice are there. In a dice, you might have played a game of dice, Ludo, you know, that when you throw a dice, what can you see, what the number can be appeared at the top of the dice? Obviously, it will be either 1, as you have seen here, either 1 or 2 or 3 or 4 or 5 or 6. So, every number are single. It means in a coin, the surfaces, first number answer, for surfaces are 2 surface, they are head and tail, dear student. And in case of when throwing or rolling a dice, then what surfaces can you observe when you roll a dice? What appears at the top surface? The appeared number in the dice can be, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5, or it can be 6. Look, can you see 7 number at the top of the dice when you roll a dice? No, it is impossible. Can you see 0 appearing 0 in the dice? No, it is impossible, because in the dice there is no 0, no 7. The numbers in the dice are 1, 2, 3, 4, 5 and 6 only. Next question, dear student, let me see the third question, please. What are the colors of playing cards? So, dear student, if you see the PIP, you can easily observe the colors. If we just talk about the colors, actually there are 2 colors, you see, like 2 are red in color and 2 are black in color. You have seen in PIP clearly. Heart and diamond, red in color, spade and club, black in color. So, in playing card, there are two colors, they are red and black, red cards and black cards, and then out of 52 dear student, as there are two colors, 50% belongs to red color, 50% belongs to black color. Red and black two colors are there. You have seen in PIP, no need to explain. Next, how many surfaces are there in a dice, or what surfaces with a number can be observed when a dice is rolled? Same like second question, we have already discussed, and you can see here easily in a dice. In the picture also it is clear, dear student, you can see 1, 2, 4, 6, 5, 3. They are shown in these two dice there. So, they are the number can be appeared in the dice. Next question, what is the probability of occurring an ace when a card is taken randomly from the deck of playing card? Now, we have entered into the term probability. Now, what is the chance that, let us suppose I have deck of 52 playing cards. I have 52 playing cards and I want to pick up a card there randomly. At random means without a plan, without looking, randomly I want to pick up a card. What is the probability that the card I picked up is an ace? A question related to probability is asked. It is so simple, dear student. You just need to notice two items when you learn about probability. When you learn about the calculation of probability, you should remember how many aces are there. Like probability of ace is asked here, you can see how many aces are there. There are 4 aces. And what is the total number of cards? Total number of cards, they are 52. So, if you are given to calculate the probability of getting an ace, you need to remember the number of aces and total number of cards. So, number of aces is divided by total number of cards will give you the probability of getting an ace, that we discuss later on. So, similarly in PIP we can again let us see some defined terms in probability. So, let me show you in the full slide please, so that you can read it well. Okay, experiment. Before calculating the probability, you should have the knowledge of experiment. When we make an experiment, then only probability exists. Like last time, picking up a card was an example of an experiment. Okay, now let us see the definition of experiment in the slide. Yeah, in general, an action which is used to observe the possible outcomes for the probability of an event is called experiment. An action which is used to observe the possible outcomes for the probability of any event is called experiment. So, look at me now, please look to the board. Look, an action, I have a coin, yes, and I am going to make an action, I am going to toss a coin, yes, in order to find the, in order to see the probability, in order to learn the probability, in order to know whether tail occurs or head occurs, like this. This is called an experiment. I did an experiment and I got that head occurs this time. This is known as an experiment. And when a coin is tossed, what may occur? Either head or tail. What are the, how many options can be occurred? What is the possible outcomes? Like look, I have again tossed a coin, something is occurred there at the top surface, I have not seen yet, yes. So, what may occur at the top? What are the possible outcomes? Possible outcomes in the case of coin are either head or tail. These are known as two possible outcome. And then experiment, I have just told you the action we made for probability. Similarly, let us see next slide. Okay, now random experiment. Any experiment the outcome of which cannot be predicated or determined definitely in advance is called a random experiment. For example, some random experiments by using coin or dice. Random experiment, we do not predicate it, we do not determine before something occurred. That is known as random experiment. We do not plan for something special to occur, that is known as random experiment. Similarly, next slide you can see outcomes that I have already told you. In the case of coin, while tossing a coin, the occurrence of head or tail is the outcome. Similarly, in the case of dice, when we roll a dice, at that time, like occurrence of 1, 2, 3, 4, 5 and 6 at the top surface of the die is it is known as outcomes. Next, event. Any subset of sample space of an experiment is called an event. For example, while tossing a coin, the sample space S is equal to H and T. It is then H, T, both H and T and null sets are known as events. When we toss a coin for 2 times, or when we toss a coin, in that case event means getting head is an event, getting a tail is an event, getting either head or tail is an event, getting nothing is also an event. So, either head or tail 100% chance, getting nothing it is impossible because we take experiment in a plane surface. So, we assume that either head or tail should be occurred. So, after event, sample point, you can read, dear student, each result or event of a sample space of an experiment is called sample point. For example, when a dice is tossed, 1, 2, 3, 4, 5, 6 all are sample points in sample space. Actually, sample space means the set of sample space means 1, 2, 3, 4, 5 and 6. This is the set of sample space. Sample point means particularly 1, 2, 3, 4, 5 and 6. These are particularly sample points in the sample space of 1, 2, 3, 4, 5, 6. Elementary event. So, you can also read it, you can watch it well about the definition. This is important one, later on you learn probability easily. If the number of elements of an event is only 1, then the event is called an elementary event. For example, while rolling a dice, 1, 2 etc. are elementary events in the sample space S is equal to 1, 2, 3, 4, 5 and 6. Now, let me clarify this please. Okay, dear student, this is a coin. When I toss a coin, either head occurs or tail occurs. How many head are there? Single head. How many tails are there? Single tail. Similarly, if you roll a dice, dear student, either 1 occurs at the top surface or 2 or 3 or 4 or 5 or 6. 7 impossible, 0 impossible. 1, whether 1 can be at the top surface of a dice when you roll? Yes, obviously there is chance. How many 1 are there? Single 1. How many 6 are there? Single 6. How many 4 are there? Single 4. This way, in case of rolling a dice, in case of tossing a coin, all the events are single in number. So, such events are known as elementary event. But in case of playing cards, how many aces are there? 4. How many 2 are there? 4. This is different events. Okay. So, after this, again let me show you the slide please. Okay. So, this is the definition of elementary event with an example. Next, okay, equally likely outcomes. The outcomes are said to be equally likely outcomes if the probability of possible events of an experiment are equal or same. For example, while tossing a coin, the probability of occurring head or tail T is equal. So, dear student, let me again explain it. Look at the coin, please. Yes, as you have just studied, this is a coin. I toss. There are two options, possible outcomes, two possible outcomes, tail, and there is one tail, there is one head. Both have 50-50 chance. Such events in the tossing, while tossing a coin, the events head and tail are known as equally likely event, because the probability of getting head or the probability of getting tail, both are exactly same, equal. Okay, again from the slide, please. So, this is what the definition of equally likely outcomes. A number of favorable outcomes. Now, favorable, new word, it is clear by the term favorable. The outcomes which are in your favor are known as favorable outcomes. For example, look, which are desirable to us is called number of favorable outcomes. For example, dear student, if you are playing a card and your desire is to get an ace. So, what is the number of favorable outcome there? How many aces are there? There are 4 aces. So, number of favorable outcomes will be 4. While tossing a coin, if you if you want tail to occur, so how many tails are there? Single tail, one tail. Therefore, the number of favorable outcomes is 1 there. Finally, the probability of an event is given there, the student. And now, let me see this slide in PIP, and I am going to discuss in the board, please. Look, finally, probability of, let us suppose here, getting a tail. This is the question in PIP also, you can see, but I am focusing you here, a student. Now, in short, in short and little faster maybe, I have completed some the definition or some knowledge about the some useful terms that are used in probability we discussed, and now we have come to probability of particular event. And here I am going to discuss when a coin is tossed, either head occurs at the top or tail occurs at the top. Now, we are talking about what is the probability of getting a tail when a coin is tossed. Now, the probability of getting a tail you need to find, you need to remember that here a number of favorable outcomes. Number of favorable outcomes, dear student. So, favorable outcome means if we are looking for a tail, favorable outcomes means number of tail. How many tails are there in a coin? One tail, yes. And what is the set of sample space? Sample space means all the possible outcome. It is good to write it at first. Set of sample space has two elements, they are head and tail. So, what is the number of sample space then? Number of sample space n, yes, is it? You can count the element 1, 2, how many elements are there? Obviously 2. So, this is the number of favorable outcome and this is the number of total possible outcomes. So, dear student, finally, we have reached to the calculation of probability of getting a tail or getting a head, like that. Simply now remember, probability means a chance of occurrence. Nowadays like some football matches going on, IPL is going on, many of you may be interested for watching IPL. You have selected your favorite team there, that team plays, and what is the chance that that team will win? 50%, because 50% your team wins, 50% your opponent wins. So, we talk about chance every time, every time we used to talk about the chance. In fact, mathematically that chance is known as probability, and here we are going to calculate the chance of getting a tail when a coin is tossed mathematically. Okay. So, number of favorable outcome for, we are looking for a tail. How many tails are there? One tail is there in a coin. So, number of favorable outcomes NT is 1. Sample space, the set of sample space in case of coin is H comma T. So, number of sample space, set of sample space has 2 elements H and T. Therefore, number of sample space means cardinality of set S, it is 2. And finally, then probability of getting a tail is equal to probability of, look, tail we have already denoted by T, PT. This is equal to number of favorable outcome upon number of all possible outcome or sample space. I wrote here possible outcomes, it means, dear student, number of sample space as well. Number of favorable outcomes, if you are looking for a tail, so number of favorable outcome NT we have got, and number of possible outcomes means NS. This is the formula. How many tail are there? One tail. How many number of sample space? 2. This is the answer. So, dear student, this is the probability of getting a tail when a coin is tossed. Similarly, okay, now let us see the slide. Till then I will show you, I will prepare for the next question. Slide please. This is what we have just done. Now, there I have written, dear student, what is the probability of sure event and what is the probability of impossible event. Please keep on thinking please. What is the probability of sure event and what is the probability of impossible event? Okay. Now, may I draw your attention to the board please. Did you think it? Sure event means, if we toss a coin and we want either head or tail, and we are tossing in a plain surface like glass, there is no chance for a tie, So, either head will come or tail will come for sure. This is known as sure event, and here you need to remember that probability of sure event is 1 and the probability of impossible event, like when you roll a dice, can you get 7 there? Can you get 7 when you roll a dice? No, it is impossible. Is there any chance? No, not at all. So, what will be the probability? 0. So, remember that probability of sure event is 1, probability of impossible event is 0. Therefore, dear student, very important thing, therefore, the probability of any event lies between 0 to 1, from 0 to 1. 0 can be of impossible event, 1 can be of sure event. So, probability means the value of probability must come from 0 to 1, 0, 1 or in between 0 to 1, that will be the probability of any event. Now, simply I do not have more time, just I am going to show you one example more, that is all. While rolling a dice, dear student, let us suppose we are looking for 6. What is the probability of getting a 6? This is the question. what is the probability of getting a 6. For that, at first we write the set of sample space yes, it is 1, 2, 3, 4, 5, 6. Then therefore, number of sample space n s will be 6. 1, 2, 3, 4, 5, 6 numbers are there. And what is our favorable outcome? We are looking for 6. What is the probability of getting a 6 is the question. Favorable outcomes, let us denote it by f is equal to 6. We only want 6. We want this 6, dear student, do not be confused. This 6 is there and this 6 is the number of element. Okay. This 6 is the 6 that can be appeared at the top surface and this 6 is the number of elements. Therefore, number of favorable outcomes will be how many elements are there? 1. Then probability of getting 6 when a dice is rolled or dice is thrown, that we have supposed as f, dear student. For 6 we have supposed as f is equal to number of favorable outcome upon number of total possible outcome. 1 6 is there in the dice, total 6 numbers are there. Do you think you have understood? I hope you have understood it very easily. It is because it is simply probability means you can see in PIP one more example, the one example I have done there in PIP you can see. So, dear student, we have just learnt about the probability. Calculation of probability means simply please remember probability of what you are calculating, keep its number at the numerator and total number at the denominator, it gives us the probability of getting something. Next, probability can be represented in decimal, probability can be represented in percentage and probability can be represented in fraction. Many more to go, but time is not supporting us. I should end my class here. See you next time. Till then, goodbye. Have a nice day. Thank you.